So hi, everybody. My name is Miriam. I'm the data advocate here at Data, and today I'll be talking to you a little bit about data quality, how we can profile our data, and using Pandas Profiling, or should I say data profiling, you'll see in a bit, to do this. So the main idea today is to go over the importance of data quality in this new paradigm that is data-centric AI. Go through the complexity of handling real-world domains that we often face, and then exploring a real-world data set, which I find would be more useful for us to discuss some details. Basically for the past couple of years, we have talked a lot about building better models, more robust models that can handle so much of data peculiarities. But right now, we are evolving towards a more data-centric paradigm, which puts data and its quality in the centerpiece of the data science lifecycle. So we are coming to the realization that data or big data is not necessarily quality data, and that we even may get better results with a simpler model if our data is smart. So moving from this raw data or imperfect data into intelligent and actionable data is precisely what we call data-centric right now. And this leads us from, instead of creating biased or unfair models, to create accurate, reliable, and insightful models. So this is mainly the idea of working around, evolving our models around data quality and not the other way around. Real world domains as everything that is human. We are human, we are imperfect, we generate imperfect data. And so we need to handle it on the other side. For real world domains, we have large amounts of data, or sometimes very few amounts if we're working with rare events, rare disease, and so on, produced within milliseconds. They can be managed by so many people within organizations, collected in different formats, sources. They can be structured, heterogeneous. They can be audio, video, image, whatever. And they can be sometimes decentralized. So additionally, it brings some challenges when we are trying to merge from different sources during our normal ETL processes. But besides that, we could define what we call true imperfections, or something that went wrong during the acquisition, transmission, or storage process, versus what we call the nature of the domains itself. This means that there are issues that may not derive from the acquisition or transmission process, but rather be a reflection of the own nature of the domains, just such as, for instance, missing data. It could be both or the other way. This is one of those cases, but imbalance or underrepresented data, even outliers, can be due to the very nature of the domains itself. And then we have other complications for some domains, which are: do we get interpretable or explainable models? Is this a high-stakes domain? Privacy concerns, which is also a high trend in AI today. Availability, fairness, ethics, and so on. However, despite this is a challenging type of paradigm, it is also the one where we can have great transformations from now on. These are some data quality issues I've selected here today to discuss with you. Well, imbalanced data essentially refers to this disproportion between classes. It is problematic since standard classifiers are normally biased towards most represented concepts. And normally the class that we wish to actually highlight or predict could be the minority one. Then we have underrepresented data, which is linked to another form of imbalance. So here we have between class imbalance, and here we have within class imbalance, where there are a few clusters. These are called small adjuncts of the same class, which have different characteristics, and these are hard to get by the classifiers. They tend to overfit them and then fail for new points. And finally, missing data. So this corresponds to the absence of some values in data. Some classifiers cannot handle missing data internally. And when they do, they even might be compromised by the results they generate with this absence of information regarding the complete domain. So getting to profile the data, which is essentially the process of continuously iterating, assessing, improving data, is essential for any project of data science right now. It encompasses a lot of tasks. It might be just summary statistics to investigating deeper interactions between features, correlations, and so on. And it is often very thorough and very time consuming, even if we are considering smaller data sets. But when big data comes into play, and surely you have a lot of experience in this, the technical debt increases exponentially. I mean, increases in effort, increases in time, resources, people, and expertise. And oftentimes this leads to data quality and profiling being overlooked during the process. And by doing this, we are turning our data pipelines into a nightmare to manage and also generating unreliable analytics. So normal solutions to handle larger data sets could be, for instance, custom solution, which is sort of for looping and printing a lot of information on, for instance, our data frames, which is impractical, time consuming. There are no visual profiling solutions so far. Or we could, for instance, considering subset of data. This is not ideal, of course, because we are under the impression that that subset will be representative of our data. And it is impossible at the moment where we don't have any prior information on the data to know that for certain. So for this reason, why data profiling or Pandas profiling, as you probably know it before, has been renamed to data profiling due to this extended support now for Spark data frames. Essentially, the overview is the same. Of course, this is just a new version. It's still open source, nothing has changed there. Okay, and the profiling report overviews several aspects of our data or our exploratory data analysis. So it supports both tabular and time series data. It presents an overview of the data and its main characteristics. Then we can zoom in on each variable and see its main characteristics, and we can evaluate interactions and correlations between variables. The most, or for me, the most interesting feature is really the data quality alerts. It comprises several warnings on the data that could be due to the acquisition or transmission processes, redundant features, irrelevant, inconsistencies, and so on. But it also can give us some hints on the nature of the domain itself with, for instance, imbalanced data alerts. I will show you perhaps with a short use case. So this is the HCC dataset. It is essentially a healthcare dataset where we have clinical and demographic variables from a set of patients. And the objective could be, for instance, to determine whether that patient will be alive or not in a year. So the survivability of the patient. And it is a quite interesting dataset because it has a lot of inconsistencies, but also problems that arise naturally for this domain among imbalanced, overlapped data, underrepresented data, missing data, and so on. So I essentially took out a subset of features for this data set, and I introduced some peculiarities in it for us to evaluate more deeply the functionality of wide data profiling. So for this case, I just added this variable O2, which is basically the oxygen saturation, and you can see that it has only 999 points. Also, for this variable, I took out every yes value. So this could be mimicking a particular mechanism of missing data, which is missing not at random. And then you can see also that the hallmark has some funny values, which is basically the concatenation of its true value, yes or no, with something that could be like a quasi-identifier or something, because it is associated with perhaps an index or something that could be an ID, which is different for each patient. Profiling this data set will be super simple. So just pip install the package. We can call Pandas to read our data set, import the profile report from data profiling, and then we can do it basically in one line of code. We just call the profile report within our data frame, and then we can generate the report in HTML, a JSON file, or we can read it within the widgets of a Jupyter notebook, for instance. For this case, I have it here on my Jupyter notebook, but also I have essentially exported the report to show you in a more neatly way. So there we have it, the alerts that web data profiling generates for this data set. We can see that it automatically highlights the fact that HBEAG is a constant, O2 as well. And for instance, for all mark, it says that it is uniform. Of course, it's unique as well. Encephalopathy has a little bit of imbalance, and a lot of features have missing values and high correlation. So then we can check the specifics of each variable, which could be interesting. For instance, let's check here full details for the numeric feature, which is presented as an histogram. We can check, for instance, for extreme values. This would be perhaps not ideal ages to have this liver initial disease, which is basically a primary form of cancer. So we can automatically check here if there are subgroups that we might have to look into. Then for binary or nominal values, we have the bar charts and the frequency where they occur. For instance, Hallmark presents 3 types of different alerts. We can automatically see that, okay, for 100% of distinct values, there's probably something that we need to reject. And also, for instance, the great imbalance that we saw in encephalopathy. In this case, we may have to use some data augmentation on these types of categories. For other types of features such as gender or race, for instance, this could be a strong indicator of possible bias going forward. So this is how we can get an overall feeling of our data set. For interactions, we have this pairwise scatter plot. We can see, for instance, age and hemoglobin, or total bill and perhaps direct bill, which are often correlated. And then we can zoom in on these correlations further with the correlations heat map or the table. For instance, we can see here that the total bilirubin is directly associated with the direct bilirubin, precisely because the total is the sum of the direct and indirect, something like this, okay? For missing values, we can check the count. So we have a lot of features here missing. Also the nullity matrix, which gives us a nice insight on how many records are missing for each feature. And the heat map, which could be informative to diagnose potentially missing data mechanism. Okay. For instance, we can see that where total bill is often missing, hemoglobin is also. This could be, for instance, these are laboratory results, and when one value is not taken, the other is not as well. Something wrong with the blood sample or other possible situations that cause the missingness to be related. And finally, we can see the first rows, last rows, and in this case, there are no duplicate records, but they would appear below. Additionally, we can, for instance, get the comparison between 2 profiles. This is helpful when we are trying to, for instance, make some transformation on our data and see how it worked out. So in this case, what I did was, let me just show you here the ferritin feature, which has a lot of missing data. And so what I did was simply get this imputed with not a random, but a mean method. So I take just the mean of the values and input it. Since this has almost 50% and we have a high range of values, of course, our result was that most values were imputed here, and this, of course, does not mimic the properties of the original data. So this means that this was not an adequate missing imputation strategy to fill in the gaps. Now, with this comparison report, we can have, for instance, a way of assessing not only any type of transformation, but for instance, for imbalanced data, we can check if possibly generated new data, synthetic data, is mimicking the properties or not, if the data augmentation method we are using is the best one. For missing data as well, we can compare between several missing data imputation strategies. And even for data shift, we can compare different time frames and see how the data is evolving. So all in all, there are several use cases that you can put wide data profiling to the test. Beyond, of course, exploratory data analysis and visualization. Now, with extended support for Spark, you can always put it to the test for your big scale or large scale use cases. You can, for instance, take a daily snapshot of your data and see if anything changed in the data requirements, sources, formats, schema, and this boosts your ATL significantly. You don't have to spend so much time trying to understand why your data flow is breaking at that day. And as well, for instance, for machine learning engineers to understand what is happening to the model, why is it drifting, why is it outputting erroneous predictions that day, you can check for quality control, check what's happening oftentimes in real time, check for rare events, data drifts, and other types of problems. Finally, before I leave you, I just wanted to give you a small preview of the data-centric AI community, which is essentially a space where you discuss this data quality best practices for data science. So we are a group of data scientists interested in sharing best practices, approaches, new ideas, and discussing strategies, and also collaborating to open source software. We have recently a Medium publication where we talk a lot about several aspects under the data science, a lot of tutorials to follow up on open source tools, comparison of tools, and so on. And also our curated space is currently on Discord, where we discuss some questions, some often troubleshooting on Pandas Profiling, wide data profiling, or wide data synthetic. And so we get to communicate and do a lot of events. Beyond wide data profiling, which is a data profiling tool, we have also data synthetic, if you like to explore it. It's just a way of generating artificial fake data to replace your original data for privacy concerns, data sharing, and so on. And we often get monthly events such as the Data Quest and Data Dojos, which are for discussing a particular trend topic in AI or get a hands-on tutorial in an open data source. If you are interested in following up on this, please just let me know and we'll get to that. Beyond this, you can find us on the datacentricai.community and also subscribe to our newsletter to get always the full events. I think that's it. Thank you so much for this opportunity, and hopefully I'll see you around very, very soon. Bye-bye.